안녕하세요, 윤스키친입니다. 오늘은 멀로 영상 파트 2입니다. 감사합니다.
Hi everyone, hopefully you saw the first video, but we're picking up with the second video looking at the Lucid underbody. It's been super exciting going through all the different things that we saw in this. And so last time we talked about the front end. Today we're going to pick up roughly at the leading edge of the battery pack and work our way rearward. So hopefully we get to the end of the day or the end of the vehicle today and not leave you hanging. So as a couple of things that we just kind of wanted to wrap up at the rear end of the vehicle. We talked a little bit about the structures on the battery pack versus the body structure, how those are tying in together, why that might be a good thing from a structures perspective. So one of the other things that we wanted to mention before we move on to the battery pack was from a packaging perspective. Grace, if you'd swing out to the outboard side here. This is something that we rarely see. This whole black blow molded bottle right here, so this whole section right here, that is the wiper fluid reservoir. So we see a ton of them that are mounted inside the fender, some that are even tucked a little bit inside the fender, but Lucid actually took it all the way to the bottom, and if you look right here, they've got these little rubber ball studs that they're pushing it into. And so they really made a pretty concerted effort to get that as far rearward and as I'll say shrink wrapped as much as they possibly could in this zone. Once again, if you'd seen the first video, they did an excellent job, in my opinion, at maximizing the available space for the frunk and really providing enough free crush space in the front of the vehicle to get the characteristics that they wanted to from the front end. So just another enabler. And then if we go to the other side, in a similar vein, right here, both the brake lines and one of the coolant lines just essentially plug right into, with the coolant case, the body structure, and then the brake lines traverse inside this sill section fore aft in vehicle, right? So what they're doing with that is they're really maximizing the available space that they have intra battery pack. So how much energy can you carry? Them taking some of those other monuments outboard of the battery pack really enables them to package as much energy as they possibly can within the battery. So now getting into the battery, there's a lot of different videos on the battery out there, and there's some really interesting things about the overall execution of this. One of the first things that I would point out is the thickness of this bottom plate on the battery pack. If you were to look at the cross section of this, I mean, that's probably 7 or 8 millimeters thick. And so, and not only is it thick, this is a incredibly rigid, fibrous, like a resin impregnated fibrous monument that is closing out the bottom of the battery pack. So not only is that providing incredible, I'll say, shear structure to the battery pack, right? So stiffness across its axis or in that plane, but it's also providing, presumably, really good ingress or puncture protection for debris, hazards, anything on the road going from the roadside through into where the batteries live. So this is a really important piece, but this is super costly. These panels are not inexpensive whatsoever versus a more conventional extruded floor or stamped steel or a stamped aluminum floor. This is going to cost you a pretty penny, but there are some benefits to doing it. As we go to the outboard side, what they've done is they've capped both sides of the battery pack on the outboard with aluminum extrusions. It is interesting looking at how they nested the aluminum extrusions around that bottom panel. So if you look at this little joint right here, maybe Grace, go from the end of it, so further right there, yep. If you look right here, that aluminum extrusion actually slides over, almost like tongue and groove style, and then they put some structural adhesive to really ensure that those two are bonded together. Not only did they put structural adhesive, if you were to go inside of the aluminum extruded section, you would find fasteners coming in from the side or in the y-axis that are attaching to the actual side rail of the battery. So this is mostly side pole protection, right? It's an additional structural monument to help absorb energy. and kind of react against the barrier, especially for this new IHS, the 2.0 or the updated side pull test, whereby the barrier is lower and it's a little bit more difficult of a test to score well on. There are some cross members within the battery pack that are providing some additional structure. The only downside about having fasteners like what we see right here is not potentially, these are leak paths. Anytime you have a fastener going from the exterior environment inside of a battery pack or whatever monument that you want to keep air quote dry, a fastener is introducing another leak path. So general practice, we try and refrain from having fasteners go from the outside or the environment through one of the main exterior layers into a battery pack or any area that we're trying to keep dry. As we go to the back of the battery pack, you can see one of the main high voltage runs going from the motor inverter to the battery pack, this little junction box area here. One of the things that we saw when we came to the back of the battery pack was how the top of the battery pack was enclosed to the main housing. We had a company come in here not too long ago, and we were reviewing one of their battery pack technologies. So they're a supplier, and they were talking about how they were clipping the top of the battery pack to the bottom of the battery pack. Well, lo and behold, the Lucid came in, and if you see right here, those are actually just small spring steel clips. And so for the lid of the pack to this part of the pack, this cast aluminum section in this case, they're indexing them, loading them, they've got their seals set up, and then they're taking these clips around the periphery of the pack and they're simply snapping them over the lips on all of those. Ultimately, if I had to guess, there's probably a pumpable like RTV or polyurethane seal that is in between the flange and the lower and the upper, but those clips are relatively simple. And the other great thing about the clips is they're very serviceable. If you need to drop the pack and service it, which hopefully you don't design a pack that you need to service ultimately, but if you do and you drop this pack, those clips can pop right off and they're not actually doing any damage to the upper and lower layers of the pack. So from a serviceability perspective, not a bad option. Also from an installation perspective, there's no tools required necessarily in terms of like power tools or pneumatics, torque metering, nothing of major substance in terms of the capital expenditures. So they're keeping costs low by doing those spring steel clips. Now, the spring steel clips relative to a fastener, those could be slightly more expensive per unit clip, but there are some assembly and or serviceability benefits to doing something like that. Again, looking at the back side of the pack here. Now, from this view, you can really kind of see how thick it is. And you can also tell that there's a lot of secondary processing in trimming off this piece, right? A lot of secondary routing and making sure that edge is cleaned up. And then it kind of gets goobered up with some sealer so that, you know, from the end of this, those fibers aren't sticking out or anything like that. And then right here, you can kind of see one little index point between that lower layer and the cast housing at the tail end, right? So this would be what we would refer to as a two-way locator. So it's not necessarily locating this piece fore aft, because you can see it's not touching any of the walls on the piece fore aft. It's only touching side to side. So it's a Y-axis or cross-car locator, a two-way. Typically on a battery pack like this, or anything, general automotive, GD&T practice or locating practice is a four-way and a two-way. So you want a manner to locate it either in an X fore aft or Y cross car, and then you want an absolute net locator which locates in four axes, fore, aft, side to side. Okay. So moving rearward, looking at the suspension overall in the back, we've got a large cast. It's actually a hollow cast aluminum cradle. It is isolated to the body structure versus the front cradle, which was a weldment combination extrusions and castings, but that was hard mounted to the body structure. So we say isolated versus hard mounted if we see this right here. It might be difficult to make out, but in the primary attachment points of the cradle to the body structure, there's an elastomeric or like a rubberized material that the bolt is passing through. And so from an isolation perspective, that's going to mitigate a lot of the vibrations and frequencies from this motor assembly going into the body and being perceptible to the driver, the occupants, so on and so forth. Most of the time, if you've got a rear-wheel drive or an all-wheel drive setup, the rear cradles more often than not are isolated, so very common practice in that regard. Continuing outboard in the suspension system, again, hollow casting main lower control arm assembly. This is actually providing 2 links worth of work, right? So we've got our leading link, right? So like a toe link style setup, and then our camber link, our main lower camber link. This is also the major or the primary spring seat, right? So this lower control arm provides the lower spring seat. So you can see our coil spring right there, and then that's going up to the body structure. One interesting thing relative to the lower control arm setup on the suspension is this guy right here. So this looks like, and I would actually be willing to bet that this is probably an inner tie rod from an existing parts bin. By parts bin, we mean another OEM or another company has this part off the shelf, and Lucid is simply buying it from them or from the supplier that provided it to a given OEM. And what they're doing is, instead of using it for a steering system where you've got a jam nut and you're doing this for alignments and so forth, they're using this as a toe link adjustment mechanism, right? So as you do an alignment, you're on an alignment rack, they're gonna manipulate the position of this jam nut thread in or out. Actually, you rotate about this guy right here. You rotate that in and out, and that's going to change the position or the direction of travel of this rear wheel. So kind of an odd application for an inner tie rod like what we're seeing here, but we've seen a few of them in the past, but it is very atypical. Typically you'll have an eccentric or like a Lobel type bolt, and that is going to interface with another metallic element on a control arm. When you rotate it, it changes its position and moves the control arm relative to it. Okay, as we move rearward, again, if you'd watched the front video, I was talking about the accommodations of the motor front and rear. So common front and rear motor, but they did have to modify this whole oil coolant, this heat exchanger and oil or gear oil pan that we're seeing here, this injection molded piece. Common oil pump, it looks like, from the outside. And then, as I'd mentioned, the inverter for the rear motor is packaged on the rear, right? So this is the inverter for the rear motor. So again, just kudos to Lucid for packaging things well and really thinking about how we want to, or how can we repackage or orient the motor so as to get the inverter as far rearward as possible, so as to maximize the space available in the cabin to those rear occupants. You know, there's a lot of discussion regarding H-point position. H-point position is your hip point represented in CAD relative to the vehicle, right, and the seats, and there's all these critical dimensions, right, thigh angle, knee angle, 1-2 couple, distance from front and rear. They put a lot of effort into maximizing this cabin space, and all of these dimensions really start to stack up. So as you're designing a vehicle, you need to say, where is my center line of spindle? What is my next hard monument, right? You have to place in your suspension geometry. What is my impact script demand given the vehicle mass? Meaning, how much free crush space do I need in my crumple zones, fore and aft? Now, where does my battery live? Where are my seats? How much space do I need? And all of these dimensions become super, super critical. It's not just like, can we move the seats a little bit further back? All of those things are very, very carefully metered to make sure that we're not sacrificing anything structurally. We still have room to package everything that's absolutely technically required, such as control arms, motors, and so forth. But from a comfort perspective, the customer still gets a say. So that you really want to maximize that second row spaciousness, especially in a more premium vehicle from a price point and like kind of that executive sedan style that we see here on the Lucid. Hope you enjoyed the videos. Go ahead and hit that subscribe button just so Corey doesn't get mad at me. And hopefully we'll see you next time. Thanks for joining.